Okay, the second half of the second lesson is over matrix multiplication. This is the second skill on the basic operations with matrices homework, and that is multiplying two matrices together. Now, in order for us to multiply two matrices together, the number of columns in the first matrix must equal the number of rows in the second matrix. Yes, that's correct. So I had to think about that and make sure I said that right and didn't need to start the video over. So the number of columns in the first matrix must equal the number of rows in the second matrix. And that sounds complicated, but if we understand dimensions, it really is not. For instance, if we're checking to see if it's possible to multiply A times B, what we do is we list the dimensions of A. So the A, remember we list dimensions as rows times columns. So A is 2 by 2. And B has 2 rows and 3 columns, so it is 2 by 3. And we simply circle these two middle numbers, because if those two middle numbers are the same value, then A times B is possible. Now, matrix multiplication is not commutative. What I mean by that is A times B is very different from B times A. We can't assume that just because A times B exists means that B times A exists. And if we look at it very carefully, we're listing the dimensions of A first and then B in our dimension check up above. So here we'd be listing B first, which is 2 by 3, and then A, which is 2 by 2. And when we circle those middle numbers, these are not the same value, which means B times A does not exist. And if it doesn't exist, if it's not possible, then we simply answer with, as we have in all the other problems in this unit so far, the null symbol. So that's the explanation on how we know whether or not it's possible. Now we have to talk about how to actually do it. And this is a big time important skill. It is a big time important skill because this has a lot of applications, and we're going to be looking at a lot of those applications. So we need to fully understand. We need to fully understand this process. It is very, very important. Okay, so here we have matrix A and matrix B. We are going to start off doing the one that actually does exist, A times B. So we're going to do A times B. Now again, I would suggest always that your first step be to neatly rewrite the two matrices that you are multiplying directly next to each other with lots of spacing, okay, very, very neatly. Because matrix multiplication, while it is not a very difficult idea, is an extremely tedious idea. So what we're going to do is we're going to use the rows from the first matrix, so row 1 and row 2, to multiply the columns of the second matrix, column 1, column 2, column 3. So we start off working with row 1 of matrix A, which is 3 and negative 2. And we're going to multiply the first column of matrix B. Now when I say multiply, that's really more of a sum of different products. So what we do is we do 3 times 3 plus negative 2 times negative 1. So that's the first element multiplied plus the second element being multiplied. And this number will reduce down to one number in our answer matrix. Now notice where that is located in our answer matrix. That sum is located in row 1, column 1, which was, it came up with it by multiplying row 1 times column 1, so it has to be in location 1, 1. We're going to repeat that step using row 1 and column 2. Actually, let me mark this as being the yellow so we can have that marked that way. Okay, so row 1 times column 2. That's 3 times 5 plus negative 2 times 2. And again, we will eventually narrow that down to one number, but I want to see this work step. I want to see that you understand it. 3, negative 2, we're doing row 1 times column 3. So that's 3 times 0 plus negative 2 times 3. And that'll be our last entry on the first row, because I've now used row 1 to multiply every single column. All right. Next up, we have row 2 times column 1, which again will be located in row 2, column 1 of our answer. 1 times 3 plus 0 times negative 1. Okay. Then we're going to do row 2 times column 2. That is 1 times 5 plus 0 times 2. And then finally, row 2 times column 2, or 3. Row 2 times column 3. So 1 times 0 plus 0 times 3. Now, as I mentioned, each of these is going to reduce down to a single number. So our final answer, we're going to take each of these sums and reduce them down to one number. So we have here 3 times 3, which is 9, plus negative 2 times negative 1. So that's 9 plus 2, or 11. 15 minus 4 is also 11. 0 minus 6 is negative 6. 3 plus 0 is 3. 5 plus 0 is 5. And 0 plus 0 is 0. So our answer would be 11, 11, negative 6, 3, 5, 0. Now, as I mentioned before, b times a can't be done, right? b was 2 by 3. A is 2 by 2. So right there, we know this is not going to work. So since it cannot be done, if I ask you for that, you would simply answer with, that's not possible, empty set, no solution. So you would simply answer with the null. Now you could also write no solution. I'd be okay with that. But the preferred math approach here, for me at least, is to use the null symbol. Okay, that brings us to C times D, which is the last example. Again, I would highly suggest that you write out both of the matrices that you are going to be multiplying. And by the way, C times D does exist, because C is 2 by 3 and D is 3 by 2. So those middle numbers check out. So we are multiplying. 4, negative 1, 5, 3, 2, 0. Alright, so that would be, and this is going to look a little bit worse than the other one, but in reality it's a little bit less work. We're going to do row 1 times column 1. Notice how there's 3 sets of numbers that were being added up now. So we do first times first, 4 times 4, plus second times second is 2 times 5, plus third times third is 3 times 2. And that will be our entry in row 1, column 1. Then we do row 1 times column 2. So again, first times first is 4 times negative 1. Second times second is 2 times 3, so plus 2 times 3. Third times third would be plus 3 times 0. Okay. Then we do row 2 times column 1. So first times first is negative 1 times 4 plus 0 times 5 plus 2 times 2. And then finally, row 2 times column 1. That's negative 1 times negative 1 plus 0 times 3 plus 2 times 0. Finally, we're going to reduce each of those sums down to one number. 16 plus 10 is 26, plus 6 is 32. Negative 4 plus 6 is 2, plus 0 is still 2. Negative 4 plus 0 plus 4 is 0. And 1 plus 0 plus 0 is 1. So C times D is 32, 2, 0, 1. That does it for matrix multiplication.